Hey everyone, it's Justin again. In this lesson, you're going to be learning about the volume of composite figures. You will be using all of the volume formulas you've learned so far in this unit, so make sure you have your notes on prisms, cylinders, pyramids, cones, spheres, and hemispheres nearby. By the end of this lesson, you will be able to find the volume of composite 3D figures. First, we'll discuss a general approach that can help you set up and solve these types of problems. Then, we'll practice visualizing what simpler figures make up composite figures. And finally, we'll complete an example problem. So, what are composite figures? They're figures made of two or more easier figures that we already know how to calculate. Since volume represents space inside a figure, we can calculate the volume of each 3D shape that we know how to, and then add them together. For example, how can we calculate the volume of this? For this example, we would take the volume of this prism and add it to the volume of this pyramid. You've already learned how to calculate the volume of each of these figures separately, so the only extra step would be adding them together. So how would you find the volume of this figure? This would be the volume of a cylinder plus the volume of two hemispheres. We know how to calculate each of these volumes separately, so the extra step would be adding them together. Or, if we want to be a little more efficient, since these two hemispheres make a sphere, we could calculate this part as one sphere instead. Okay, so we just looked at some examples of adding volumes together, but what would we need to do here to find the volume of this composite figure? Let me help you visualize this a little bit more. If we flipped this figure over, the pyramid we took out creates a hollow section that we could fill with something like water. And since this space is on the outside of the figure and not part of the enclosed space, it doesn't count towards the volume of the figure. With this additional information, do you know how we can calculate the volume of this figure now? We can use subtraction to calculate the volume of some of the figures in this lesson. In this case, we would take the volume of the entire prism and subtract the volume of the pyramid. We already know how to calculate both of these volumes, so the additional step would just be to subtract the pyramid's volume from the prism's volume. Let's try an example problem. This says to calculate the volume of the figure shown, and round your answer to the nearest tenths place. There are quite a few lengths given in this picture, so let's take those away for 1 second, just so we have a chance to visualize what figures are being used to create this composite figure. The figures that we've learned how to calculate the volume of are prisms, cylinders, pyramids, cones, spheres, and hemispheres. Will any of those help us here? We're actually only going to be working with cones in this problem. So how could we use cones to help us with this? We could take the volume of this whole cone and then subtract the smaller cone off the top of it. That leaves us with the figure that we're supposed to find the volume of. So now that we know we need to find the volume of this big cone and then subtract the volume of the little cone, let's bring our measurements back into the figure. This might seem a little intimidating, but I think you're ready for it. I'd like to see you calculate the volume of the big cone minus the volume of the small cone. Pause the video here and take all the time you need to do this. It'll be a really good way for you to determine if you're ready for the practice game. All set? Let's start with the volume of the big cone. Here's our formula for the volume of cones. The area of the base of this big cone is pi times 9 squared. And the height is, wait a second. What is the height of the big cone? It's 7.25 plus 4, which is 11.25. Let's bring that up here for safekeeping. Now we can set up an expression for the volume of the small cone. We'll use the same cone formula again. The area of the base this time is pi times 5 squared. And the height is 4 centimeters. Let's take that expression and bring it up here. Then let's bring down the subtraction that we decided on earlier. If you weren't able to get this far on your own earlier, pause the video now so that you can catch up, rewatch any parts of this that will help you, and then use a calculator to get your final answer. When calculating 1/3 times pi times 9 squared times 11.25 minus 1/3 times pi times 5 squared times 4, you should get 849.5 when rounding to the tenths place, with units of centimeters cubed. Now you can calculate the volume of composite figures. Be sure to take the time to visualize how you're going to set up your equation first, and then be extra careful when substituting your values in. Finally, you can calculate that final answer. Good luck on the practice game, and I'll see you next time.